Northrop Grumman's Lumberjack program is shaping up as a flexible, cost-conscious addition to U.S. strike options. Built around a small, jet-powered airframe with a modular central bay, Lumberjack is designed to be launcher-agnostic so it can be deployed from ground, ship, and air platforms. The core concept is simple: provide American commanders with an affordable, loitering strike asset that can deliver a variety of effects, small precision kinetic strikes, electronic attack, or sensors, and do so from safe standoff ranges while preserving more valuable platforms. Technical and performance profile: the airframe is similar in length to the GBU-39 small diameter bomb, giving it a compact footprint that fits existing SDB-sized racks and internal bays on several platforms. Published program materials and company statements peg the all-up gross weight at around 290 pounds when configured with fuel and payload, while the dry structural core without fuel or payload is about 79 pounds. Cruise speed is expected to be in the neighborhood of Mach 0.3, roughly 230 knots, at medium altitudes around 20,000 feet, and Northrop has described the expected unrefined range as several hundred nautical miles, a number that naturally varies with payload, fuel load, and mission profile. That combination of compact dimensions and jet propulsion gives a balance of endurance, speed, and payload flexibility that is useful for both deep standoff and area loiter missions. Payload and modularity: the central bay is explicitly modular. It can host small precision glide munitions, for example, the company's own Hatchet family alternative kinetic warheads, electronic effects packages such as jammers, or ISR sensors. Modularity allows a single common airframe to serve multiple mission sets with relatively simple swaps in the field or at a maintenance node. Northrop has emphasized open architecture and use of commercial or modified commercial components to lower unit cost and simplify sustainment. That architecture also supports integration of emerging payloads without lengthy bespoke development cycles. Integration with air and ground launchers: Lumberjack has been demonstrated in ground modes on both pneumatic and electric rail launchers, illustrating a launcher-agnostic approach that eases deployment from expeditionary forward sites, coastal launchers, or shipboard canisters. On the air launch side, Northrop has stated that it is doing detailed design work to be compatible with multiple aircraft, both crewed and uncrewed, and specifically cites Kratos' XQ-58 Valkyrie as a representative candidate. The small form factor makes it a plausible fit for existing small store racks and for internal carriage on some loyal wingman-style platforms, enabling launch from survivable nodes that can approach contested areas then release expendable munitions at standoff. Operational concepts and force multiplying effects: paired with attritable launch platforms, Lumberjack multiplies the number of usable strike or sensor effects per sortie. A single launch aircraft can carry multiple Lumberjacks, each of which can carry several sub-munitions or provide non-kinetic effects in its own right. That creates layered options. The launch platform can use its own capabilities to get close enough to release Lumberjacks that then loiter into higher threat areas, prosecute time-sensitive targets, suppress air defenses, or provide temporary electronic picket coverage. Modular payloads also permit mixed loads, some Lumberjacks optimized for kinetic pinpoint effects, others for jamming or sensing, giving commanders a palette of options tailored to mission priorities. Cost, production, and sustainment: Northrop has highlighted a target cost per effect in the roughly $75,000 to $100,000 range. That figure factors program, logistics, and mission economics and is presented as a comparison to heavier, more expensive missiles and manned strike sorties. The program's emphasis on commercial components, open architecture, and cooperation with rapid manufacturing partners such as Asareo is intended to accelerate production ramp and simplify spare parts chains. Recoverability and reuse during training are also being pursued to reduce lifecycle expense for practice events and experimentation. Software, automation, and human factors: Palantir is supplying an I per milliliter infused backend to accelerate payload integration, mission planning, and maintenance workflows, and to reduce operator workload during planning and execution. That approach supports rapid payload swaps and mission tailoring, and helps integrate sensor and targeting data into a single mission picture. Automation can shorten decision cycles while preserving human control over engagement decisions, which is an important operational and ethical boundary for weapon employment. Testing, timelines, and uncertainties: Northrop has participated in technology, readiness, and experimentation events to exercise end-to-end mission scenarios and gather operator feedback. The company has said it is developing an air launch flight test plan and working with multiple customer communities on experimentation. Estimates of range, weight, and cost are consistent with early program public materials and company guidance, but they remain subject to change as testing matures and payload configurations diversify. Several hundred nautical miles is a useful planning phrase but not a single guaranteed range figure. Actual reach depends on the chosen loadout and flight profile. Capability and tactical effects for American forces. Lumberjack supports several strategic and operational priorities for U.S. forces. It increases the number of relatively low-cost effects available to commanders, enabling distributed lethality and allowing high-value manned platforms to stay farther from the most dangerous portions of the battlespace. Its modularity supports rapid adaptation to evolving threats by swapping payloads rather than redesigning whole weapons. The system also enhances the effectiveness of loyal wingmen and attreatable aircraft concepts by providing a way to extend reach and apply effects from unmanned fleets without committing large, expensive missiles for every target. Risks and adversary countermeasures. As with any low-cost, attreatable strike system, adversaries will prioritize detection, tracking, and neutralization capabilities to blunt effectiveness. That drives the need for diverse employment techniques, distributed launch points, mixed payloads, timing and coordination with other assets, and integration with electronic warfare measures. Maintaining survivability of launch platforms, ensuring robust command and control links, and hardening logistics and supply chains for mass production of components are also important risk management tasks. Industrial and strategic benefits. Developing Lumberjack supports the domestic defense industrial base by driving demand for high-rate manufacturing, electronics, and systems integration expertise. Open architecture and modularity can speed fielding of improvements, help smaller suppliers participate in the ecosystem, and preserve options for rapid upgrades as sensors, guidance, or effectors improve. From a strategic perspective, ramping low-cost, flexible strike options complicates an adversary's calculus by expanding the number and types of threats they must anticipate and defend against. What to watch going forward. Progress on air launch flight tests and any publicized integration with loyal wingman platforms will be key. Indicators of operational maturity. Contract awards, production rate announcements, and formal experimentation with operational units will signal movement from prototype to fielded capability. Continuing refinement of cost per effect, demonstrable interoperability with multiple launch platforms, and demonstration of recovery techniques for training reuse will also be important milestones. Final note: the Lumberjack concept aligns with a broader shift in U.S. force design toward affordably scalable, modular systems that extend reach and allow commanders to apply effects in a distributed fashion. If testing and integration continue to validate the program's performance and cost assumptions, Lumberjack could become a practical complement to larger missiles and manned strike forces, increasing tactical flexibility, improving cost effectiveness, and strengthening the operational toolkit available to American forces. Numbers and timelines quoted here are those publicly stated by the developer in program materials and interviews. They should be treated as program estimates that will be refined through testing and operational experimentation.